Assalamu alaikum students. Our today's topic is the concentration of solution. So first of all we must know what is solution. We know that solution is a combination of solute and solvent. Solute is the substance which is taken in small amount and solvent is the substance which is taken in large amount. For example, if we are preparing solution of sugar in water, in this case, sugar will be solute and water will be solvent. And after mixing, we will get solution and concentration. So concentration of solution is the measure of amount of solute that has been dissolved in given amount of the solution or solvent. The amount of solute is expressed. So the unit which is used to represent the amount of solute is gram or moles. Two units are commonly used, whereas the quantity of solution is expressed. So for solution, we use unit dm cube or cm cube. The unit used for the mass to volume concentration is given. For mass, unit used is gram, and for volume, unit used here is dm cube. While for molar concentration, for mass we are using unit mole, and for volume we are using dm cube. So mole per dm cube. Let's solve example. Calculate concentration of solution in gram per dm cube. So we will have to calculate in the given unit, which is gram per dm cube, which contain 20 gram of sodium. 20 gram is the mass of sodium chloride dissolved in 0.2 dm cube of the water. Here is the volume of the solution. Formula which we will use to calculate the concentration. Concentration is equal to mass of solute divided by volume of solution in dm cube. So we must consider the unit here. So data must be entered in gram and dm cube. So mass of the sodium chloride is given, which is 20 gram, and volume of the solution is given, which is zero point 0.2 dm cube. After division, answer will be 100 gram per dm cube. So students, don't forget to write the unit. Example 15.5. Calculate 500 cm cube of hydrochloric acid contain 1.8 gram of dissolved hydrogen chloride. Calculate the concentration of the acid in gram per dm cube. So in this example, volume of the solution is given. Solution which is hydrochloric acid. Volume given here is 500 cm cube. Mass of hydrogen chloride, which is solute, is given here, which is 1.8 gram. And we have to calculate the concentration. Formula we have already used, and its units must be gram per dm cube. So in this case, we will have to convert this unit, which is cm cube, to the dm cube. So first of all, we will convert this unit to dm cube, and after that we will put data in the formula. So volume of hydrochloric acid in dm cube will be equal to 500 cm cube divided by 1000, and answer is 0.5 dm cube. For concentration of hydrochloric acid, we will use the formula mass of solute divided by volume of solution. So 1.8 gram divided by 0.5 dm cube, answer will be 3.6 gram per dm cube. Example 15.6. Calculate the mass of copper sulfate in gram dissolved in 2 dm cube of solution to get solution with concentration of 15 gram per dm cube. So in this case, we have to calculate the mass of copper sulfate. Copper sulfate is solute and unit gram dissolved in 2 dm cube of solution. So in this case, volume of solution is 2 dm cube. Concentration of solution is given, which is 15 gram per dm cube. Same formula will be used, but we have just rearranged this formula by taking volume to the other side of the equation. New equation after rearrangement will be mass of solute in gram is equal to concentration in gram per dm cube multiplied by volume in dm cube. So 15 multiplied by 2, answer will be 30 gram. Example 15.7. A solution is prepared by dissolving 10 gram of sodium hydroxide in 1.2 dm cube of water. Calculate the concentration of solution in mole per dm cube. So in this example, mass of the solute is given, which is 10 gram. Volume of solution is given, which is 1.2 dm cube, and we have to calculate concentration in mole per dm cube. So in this case, you must consider the unit. Mass is given, but answer is required in mole per dm cube. So we will have to convert this mass to number of moles, and after that we will apply the formula so that we can get the answer in the required unit. So amount of sodium hydroxide is 10 gram. Number of moles is equal to mass over molar mass. Molar mass of sodium hydroxide is 40, and answer here is 0.25 moles. Concentration of solution is mass divided by volume of the solution. So in this case, 0.25 divided by 1.2, and answer will be 0.25 mole per dm cube. Quick check 15.2. What mass of copper sulfate is present in 50 cm cube of 5 into 10 raised to power minus 2 mole per dm cube aqueous solution? So in this problem, we have to find the mass of copper sulfate. Copper sulfate is a solute, and we are given 50 cm cube of the solution. So volume of solution is given, concentration of solution is given, and you must notice that unit given here is mole per dm cube, and we have to find the mass. So to solve this problem, first of all we will find the moles by using the formula which we have previously used. So let's start. Volume given is 50 cm cube. We will have to convert this cm cube to dm cube. For that we will divide it to 1000. 50 divided by 1000, answer is 0.050 dm cube. Concentration is given, which is 5 into 10 raised to power minus 2 mole per dm cube. In first step we will calculate the number of moles by using the formula. We have just rearranged the formula. Number of moles is equal to concentration multiplied by volume. So you just multiply the given data, and answer is 2.5 into 10 raised to power minus 3 moles. And after that we will have to convert these number of moles to the grams or mass of the solute. For that we must know the molar mass of the copper sulfate, which so molar mass of copper 63.5, sulfur 32, oxygen 16. Overall molar mass of the copper sulfate will be, by adding these masses, and it will be 159.5 gram per mole. And in the last step we will calculate the mass by multiplying number of moles with the molar mass of the copper sulfate. So number of moles are 2.5 into 10 raised to power minus 3 mole, and molar mass of copper sulfate is 159.5 gram per mole. After multiplication, answer is 0.40 gram, which is the answer of this problem.